Video we'll learn about 3D shapes. So we'll learn about cuboid, a cube, a sphere, a cylinder, a cone, and finally a frustum of a cone. So let's get started. Cuboid. So cuboid is nothing but a box, a rectangle projected in space. So if we take a triangle and try to project it in 3D, then we get a cuboid. So 3D means there are 3 dimensions, right? Until now we saw 2D figures which had 2 dimensions, the x and y axis, right? So rectangle itself is a 2D figure. It has height and breadth or length, right? So similarly cuboid has 3 dimensions. One is the length, breadth and the height. Okay. So for 3D figures we define something called as a surface area. We only add area for 2D figures, but for 3D figures we have something called as surface area, which is covering the surface. Surface is just the outer boundary, right? Here the outer boundary itself is something formed by a 2D figure, so we call it as area. So for 2D shapes we had something called as perimeter, which is equivalent to surface area for a 3D figure. So if you have surface area, it is divided into 2: total surface area and lateral surface area. Total surface area is all the entire cuboid or any figure. So let's say there is face like front, back, top, bottom, left and right. So total is sum of all, top plus bottom plus left plus right plus front plus back. Lateral is only the sides, excluding the top and bottom. Top and bottom surface. So for a cuboid, these are the surfaces, right? So each surface is a rectangle and these are called as edges, and each point is called as vertices. Vertices and edges we already saw. So only difference is the surface area. So what is the total surface area of a cuboid? So if you see the front and back, it's nothing but L into H, right? It is just a rectangle. So 2 into LH. So front and back is done. So top and bottom, if you see, it is length and breadth. So 2 into length into breadth. And left side and right side. So left side is B into H, B into H. So 2 into B into H. So total surface area is 2 into LH plus LB plus BH. What about lateral surface area? It is excluding top and bottom, right? So what we have on the sides? LH, LH, 2LH plus 2BH. So it is 2H into L plus B. Lateral surface area. So if you just flip the cuboid like 90-degree rotate, it will become something like this. Right? Now the lateral surface area will change. So this and this. You see B into H doesn't come. So it depends on how the figure is oriented also. But in general it means only the sides. Okay. And we have what is called as the volume. Volume is nothing but amount it can hold, right? If you suppose say pour water into this 3D figure, how much it can hold, that is the volume. It is the capacity of how much this cuboid can hold or any 3D figure can occupy. So volume of a cuboid is L into B into H, length into breadth into height. Okay. So next we have what is called as a cube. Cube is nothing but a cuboid with all sides equal. So it is like taking a square and projecting it at an equal height also. So all sides, edges are equal. So this is A, this is A, and this is also A. So all are A. So all these are A. Okay, so what will be the total surface area? It's just substituting A here, right? So 2 into 3A square, which is 6A square. What about lateral surface area? 2 into A square plus 2 into A square, which is 4A square. And volume is A into A into A cube. So if you see for cube and cuboid, let's count the number of surfaces. So we have one in the front, one on the back, one on the top, one on the bottom, one on the left, and one on the right. So we have 6 surfaces. This is same for cuboid and cube. And number of edges. So we have 4 up, 4 down, and 4 of them joining them. So we have 4 plus 4 plus 4, which is 12. It's 12 edges. Number of vertices. Again 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 vertices. Okay. So next we'll see about cylinder. Cuboid, cube is done, sphere. We'll see about sphere. Sphere nothing but if you consider a circle and think of rotating it about this axis, like this, out of the plane. Rotating it about this axis, it will form a 3D figure, right? So it is called a sphere. Here it is like a 3D figure. So from the given point, all other points are at equal distance on the sphere. So this is again called as the radius of the sphere. You can consider a ball for an example. So it is round and a 3D figure, right? Okay. So for this we have the surface area. So here it has only a single surface. So there is no difference between total surface area and lateral. Lateral is also called as curved. So for a sphere both are same, right? Lateral and curved because it has only one surface. So the surface area is 4 pi r square, where r is the radius. Similarly, the volume is 4 by 3 pi r cube. So this is for the sphere. Next we will see cylinder. Cylinder, you can imagine example of rod. So it is straight and at the edges it is curved, right? Like it is long enough on one dimension, but on the other dimension if you see it is curved, correct? So this curvature is nothing represented by a circle given by r. So this is a cylinder. For example, rod, if you see, it will be of this shape, or even the pillars, cylindrical pillars, if you see, it will be of this shape. Most objects are cylindrical in nature. If you take a look around the objects in your house, you can figure out this shape very easily. So for this we define something called as the total surface area and curved surface area. So curved surface area is only this part, right? So this circumference is 2 pi r into this length. So we can call it by height h. Into h will be the curved surface area. It is 2 pi r h. Total surface area will be curved surface area plus area of these circles. So 2 pi r h plus pi r square plus pi r square. So 2 pi r h plus 2 pi r square is the total surface area. And we have volume. So the area of this circle is pi r square. That into the height will give you the volume. So pi r square h. So this is for the cylinder. So next we have cone. So what is a cone? It has a pointed edge and a circular base. So this is also circular. This is also curved surface. Okay, only the bottom is flat. This is curved surface. Okay, so for a cone, so the bottom radius is defined and height h is defined, and there are right angle. So we can also define this called as the slant height of the cone. So using Pythagoras theorem, L square is nothing but h square plus r square. We have this relation, and we have the curved surface area. So only the top part, right? It is pi r into L. So pi r into the slant height. Similarly, the total surface area will be curved surface area plus the bottom. So pi r L plus pi r square. So which is pi r into L plus r. Similarly, we have the volume of the cone as 1/3 into pi r square h. So for cylinder it was the entire thing, right? So if we draw a cylinder of same radius and same height, we'll have something like this, right? So this cone is actually occupying 1/3 of the volume of cylinder. So that is what it says. So next we have frustum. Frustum of a cone. So frustum of a cone is nothing but you take a cone and you cut it using a plane parallel to its base. So you cut it using a plane parallel to its base, you will get something like this. So the remaining portion is called as the frustum. So this is the frustum. Let's say this is some R1 and R2, or we can call it small r and capital R. It will be easier. So let the original height of the cone be h, capital H, and this a portion of height h, small h is cut. So this remaining part will be h minus h, right? So surface area is easy to find. So for curved surface area, we have pi into small r plus capital R into L. Okay. So it is easy to see if small r is 0, it will represent the actual cone, then it becomes pi RL, right? So total surface area is pi in r plus r into L plus top pi r square plus bottom pi r square. So volume is nothing but volume of the big cone minus the volume of this cut part of the cone, right? It is 1/3 pi r square h minus 1/3 pi r square small h. Okay. So if you also see, right, in this r and capital R, this same angle theta, you can see using trigonometric identities, you can see that if you take tan theta, you have small r by h is equal to, in this bigger triangle we have capital R by h. So this relation is also very important sometimes. So if they just give 3 variables, you should be able to find the 4th one. So that's all for today. Meet you next time. Thank you.